So, as we heard, driver assistance is making progress, but right now it really only covers cars that are in the immediate vicinity. What happens when you're in traffic and you need early detection? You need to know what's happening a mile or 2 or 5 away. Well, what do you do when there's no time to react? Here to give us some answers and a look at what's coming is Emanuel Sprung of Vector Informatic. Let's give him a warm welcome to the innovation stage. Welcome.
Yeah, thank you very much, and a warm welcome from me. My name is Emanuel Sprung. I'm working as a software developer for Vector Informatik in Stuttgart. And today I want to give you a short introduction of the communication of cars in the future. And the talk will be a bit more technical and not so marketing dependent. So don't expect any marketing slides at the end. So for the agenda, I have only a few points. So at first, I want to give you a short introduction into the topic, talk about the traffic complexity we have today, and then I show you the communication principles before I come to the end and summarize my talk. So we see now 3 well-known megatrends that appear in the automotive market. The first is connectivity, automated driving, and electrification. So within electrification, we have challenges that arise because of the different hybrid standards that of the powertrain, and also different standards for the charging technology. So the next big step for the electrification is the standardization of the inductive charging technology. Here at the Code N Festival, we also can see electric powertrain systems, like at the Post Auto, that is called Street Scooter, and we have also other activities at the ANBW booth of electrification. We see a tremendous change of the automotive industry for automated driving and assisted driving systems. We have learned that the combination of the onboard data and also offboard data that is provided through the cloud is a key element for automated driving. Sorry for that. So we have to introduce complex algorithms to manage the automated driving functionality. Holger Löbel already showed in his talk 2 presentations before how this could be working. Also, cybersecurity is a must, and fail operations have to at least hold the car for about 20 seconds under control after the first failure has detected. Also here at the Code N Festival, we have a smart that is showing automated parking functionality at the Karlsruhe at the booth of City of Karlsruhe. Now we come to connectivity. Connectivity is not only about infotainment anymore. It is also important to realize functionality for automated driving. One key element of the connectivity is to bring update and more functionality during the life cycle of the car into the car. So the car is going to be a business model through over the lifespan of the existing of the car. Tesla also demonstrated that impressively with the update of the autopilot feature and also other features that brings money to the company every day. So what we can see here is that the car it is going to introduce that the car is also part of software as a service. And now I'm going to I concentrate on the communication part of those topics and how to support the always-on feature within cars. So the question is, what do we have today? And like everybody know, we have the manual driving functions, and already like Tesla, we have semi-autonomous driving function, but the driver has always to be aware at the steering wheel. So another fact is that we have a tremendous rising number of vehicles every year, and that makes the whole system much more complex and unclear to overview. On the other hand, we have safety, and that is declining on the road because of the traffic. We have more incidents and more traffic deaths each year. So to improve the safety, we have invented advanced driver assistance systems that you already know from your own cars, maybe, like ABS, lane assistant, pre-crash assistant, and so on. That helps people to control the complex situations. But they have all one disadvantage. All the radar and cameras and so on can only see in the direct vicinity of the car. So the problem is that the vehicle can only react on that what it sees, and is not able to react more in advance to prevent crashes and so. The goal is to widen the communication range of the car, and the solution is that we can introduce wireless technology. With that, you are able to see throughout the line of sight, so we can also look around the corner because the wireless communication goes also through walls, we know all. So we can improve safety, we can improve comfort, and also we are able to support autonomous driving systems. So there are basically two communication principles that are going to be used, and they all have to exchange data. There are two different types of data that is going to be exchanged. At first, we have status information that is all time available within the car, like the position, the trajectory, the speed or heading, and we can detect events that the sensors of the car can detect, like black ice or traffic jam and so on. With that, the cars can send the data out. Others can collect the data, build up a local database, and can warn the driver if it is necessary. But, and that's the downside, we have complex detections of the events. So we have to invent powerful algorithms, like already shown in the base labs talk. And for that we have to bring more powerful controllers to the cars. The first technology that is going to be used is already known by the most people through the wireless devices you have at home. It's a standard from IEEE called 802.11. There are different extensions, and vehicles will use this extension called P, but it is using a slightly different communication range. With that, cars are able to communicate over about 1,000 meters. That is dependent on the signal strength the car is going to send out the data. And that includes that every car that will use that communication form has to have an ECU, an electronic control unit, and an antenna inside. The cars are basically building a meshed up ad hoc network, so there's no delay for authenticating like you do it at home with your SSID. They are directly connected, and can communicate. So only for clarification, there are many different words used for that communication. So maybe, yeah, you heard some of them, car to car or V2X. The picture below shows the cars can communicate all together, so every car is communicating with every other car, and also with some base stations, they are called roadside unit, that are able to transfer the data further. So for example, we have a car breakdown warning. One car is driving and get a damage, like of the motor or something, breaks down. Now it could send data out, and if other communication partners, like cars, are within this communication range, they can receive the information from the first car. The car even works as, like, you know, a wireless router or a repeater, so it can even transmit the data again and send it to further communication partners or to base stations that then are able to communicate via the internet to some traffic centers and then distribute the information to other base stations, so every cars are able to receive the warning in the distinct region. On the other hand, we have mobile radio communication based on known cellular technologies. You also already know it's UMTS, LTE, and fifth generation is already in the work. So this principle is based on the network coverage. You all know, if you're driving on the Autobahn or in train, not every time the signal strength is the best. So that is the main difference. And another difference is that there a cloud principle is being used. So we have the internet as base technology. We have an OEM that implements applications in the cloud and also has the algorithms based in the cloud. And with that, with the information of cars and the algorithms, the cloud is able to send data back to the cars if there's a need to. But we also heard in the talk from HP Enterprise before that every OEM has its own platform, and we have to, in the future, build up an open platform that is going to be used from every OEM. So we have not only cars from one brand communicating with other cars of the same brand. And basically here the data flow is to the cloud and back. And for example, I have remote diagnostics. So if the car gets broken, it can send information to the cloud. The cloud could send the information further, maybe to a garage, and they can look if the spare parts are available, or if they can make an appointment for the repair. So when does this technology is available? The Wi-Fi technology is already specified and standardized. So it basically could be in the car, but it isn't because of several problems that appeared in the last years during the standardization, like with security, and also the frequency band is, has some troubles. So, but next year, GM will release the Cadillac CTS 27, and that car is equipped with that technology for the US market. For the cellular, we already have introduced that by several OEMs, but the downside is that no common protocols and messages are available, so every OEM has to reinvent the wheel. There are also some other topics that is, has not been processed until now. So the cybersecurity has to be improved. The standardization through over the world has to be improved. So there are standards, but they are for different countries or different continents. And also the infrastructure has to be built up, like setting up the roadside stations and the infrastructure for security, for example. So what do we have? We have more complex traffic situations all over the world. We have to improve the driving safety. We can do that by using wireless communication technology, and it is very likely that a mix of both the Wi-Fi and the cellular technology will be used together somehow. But it still needs a lot of time until everyone has the technology in his own car. And last but not least, the support of the autonomous driving system is a very important topic for the wireless communication of vehicles, because it is may be the most disruptive technology we've seen in the automotive industry in the next years. Okay, that's it. Thank you very much for your time. And if you have questions, you can ask me later.
Questions? Questions? Okay. Thank you very much, Emanuel Sprung from Vector Informatic. We are over time, so we're not going to take questions, but Emanuel will be here along with all of our other connected mobility partners. You can ask them questions at the Info World. We encourage you to visit that area, get to know the people who are here. It's all about networking.